All right, so for number 1 here. Oh, come on. Okay, so how many moles of calcium carbonate are in 125 grams? So this is a type 1 mole equation problem. Okay, we're looking for the number of moles, which is which letter? N, yeah. Okay, so we're looking for N here. Don't want that thick marker. Okay, and we're told that it is calcium carbonate, so that is CaCO3. So that's going to be 40.08. Yeah, okay. There's only one calcium, so I don't need to multiply that by anything. Okay, I have 1 carbon, so that's going to be 12.01, not like what I did yesterday. Okay, and 3 oxygens, so 16 times 3. All right, so that is going to give us, okay, 40.08 plus 12.01 plus 48. Okay, so a 100.09 grams per mole. Okay, and they also tell us that we have 125 grams, which is mass. Right, so we have big M, we have little m, and we are looking for N, which means we just have to plug the numbers in to the formula. Okay, and so that's going to be 125 divided by 100.09, which should give us 1.25?
Yeah.
1.25. What are my units?
Moles.
Moles. Okay. Questions on number 1? How many people have done number 2? Let's have a look at that one then too. Okay, so in number 2, we got type 2 mole equation problem. Okay, what is the mass? What am I looking for? Little m. Okay. Okay, of 2.7 moles, what did they give me? N. All right, and they tell me that it's lithium phosphide. On your exam, will you get it like that, or will you get it in word form? You will get it in word form. Okay, Li3P, so that's going to be 6.94 times 3, so that's our 3 lithiums, plus 30.97, that's our phosphorus. Okay, so 6.94 times 3 plus 30.97. All right, 51.79. What are my units on that? Grams per mole. All right, so looking for little m means I will have to manipulate the equation. Okay, what do I do? Multiply both sides by big M, right? Okay, so that's going to cancel that, right? Big M is going to come over here, right? And we're going to have 51.79 grams per mole multiplied by 2.7 moles, right? So the moles will cancel in that calculation, and then we'll be left with grams. So that times 2.7. 139.83. What are my units?
Grams.
Grams. Okay. And guys, if you can do me this favor when we're doing a mole equation problem, circle or somehow indicate this is my final answer, Coderre. Okay. It makes my marking a lot easier because if I see the right answer, I know I don't have to really check the work very much. Okay. But if I see the wrong answer, then I know I got to go back and check all of your work. So if you can make it visible, okay, that makes the marking go a little faster. Okay, anybody done number 3 yet? Okay, or do we need a little more time on number 3? Okay, I'll give you guys a few more minutes. Keep working on 3. If you're not done 3, work on 4. I'll put them back up here. All right, for number 3. Okay, so we're looking for how many molecules. What did I say would come into play as soon as you saw the word molecules? Avogadro's number. Okay, so we know we're going to be using Avogadro's number in one of 2 ways, because the only 2 ways we use it is we either multiply by it or we divide by it. Okay, what are we going to use it for in this question? Multiply in this question. Okay, so how many molecules of Fe2O3 are in 230 grams? All right, so we're looking for the number of molecules. All right, that's going to be our question mark here. We know that it is iron 3 oxide. All right, so we got to do the 58.55. Did I get that right today? Nope. I always switch it. Oh, always switch that. 55.85. Okay, times 2, because there are 2 of them, plus 16 times 3 for our 3 oxygens. Okay, so that's going to give us 55.85. Okay, times 2 plus 48. That's our 3 oxygens. Okay, 159.7 grams per mole. All right, so now we've got the molar mass, and they also tell us that we have 230 grams of this stuff. Do I have more or less than 1 mole? More. Okay, so that's all right then. I know when I do my calculation that n should be a number greater than 1. All right, now, if I'm going to get the number of molecules, I need n, which is the only thing I can calculate right now because all I have are little m and big M anyway. Okay, so n is going to equal little m divided by big M. So we're going to take our 230 grams. We're going to divide that by 159.7 grams per mole. The grams are going to cancel. Okay, so that makes sense with our estimate there that it should be greater than 1, so 1.44 moles. Do I keep all those decimals? Definitely. I'm multiplying by a gigantic number. All of those decimals will be important when multiplying by this monstrosity here. Okay, so next thing I got to do then is calculate the number of molecules. Okay, calculating the number of molecules means taking the number of moles and multiplying by Avogadro's number, which is technically molecules per mole. So when we do that, moles are going to cancel, and we're going to be left with molecules, and we're going to get a big number. So I'm taking that, all of the decimals there, and multiplying by, in brackets, 6.02 times 10 to the 23. Okay, so I get 8.67 times 10 to the 23 as my final answer there. What are my units? Molecules. Now, I want to make you aware of something. Just because you said number of molecules and then showed your answer doesn't mean that that counts for your units. Units go after, okay? Sure, you're calculating number of molecules, but you still need to indicate that that number is molecules, okay, at the end. All right, questions on number 3? Anybody want more time on number 4? Okay, a couple more minutes on number 4. Now, here's why I gave a question like this one. Every time we do a calculation, okay, and I'm doing it on the board, do I always kind of talk myself through what my answer should look like? Okay, that's what tricks people on this question. You get a ridiculously small number when you calculate the number of moles. And people look at that number and go, well, I can't possibly have done it right. That's where you got to look at your numbers and go, oh yeah, that number makes sense. Okay, look at this number of molecules right here. Okay, Avogadro's number tells you the number of molecules in 1 mole. This number here is at least 100 times bigger than the number you were given. Would you agree? One is times 10 to the 21. The other is times 10 to the 23. That's 2 factors of 10. 10 squared is 100. Okay, so this means when I calculate my number of moles, I should get a really small number. Okay, I think it ends up being 9/1000ths of a mole. Okay, it's 0.009. Okay, so what we are looking at here then, okay, is we have that we are looking for the mass, so a type 4 problem. Okay, we have the number of molecules. Okay, and it is 5.42 times 10 to the 21. We talk about that number like it's really small, but it's actually still really, really big. It's just small in terms of number of moles. Okay, and we also know that it is nickel 2 nitrate. Okay, so for nickel, we've got 58.69. And there's only one nickel. Okay, how many nitrogens are there?
2.
2. How many oxygens are there?
6.
Right. Okay, so when we do that calculation, 58.69 plus 28.02, that's our 2 oxygens. Okay, plus 16 times 6, which should be like 96, I think. All right, so 182.71 grams per mole. All right, if I'm going to get little m, I need the number of moles. Okay, and I can get the number of moles by taking the number of molecules I have and dividing it by the number of molecules in 1 mole. Right, so if I take the 5.42 times 10 to the 21 molecules, and I divide that by 6.02 times 10 to the 23 molecules per mole. Okay, the molecules will cancel and I'll be left with moles. All right, 5.42 E21 divided by 6.2 E23. Okay, yeah, small. Okay, it's a very small amount of moles. Okay, and that's okay. We kind of figured it would be when we looked at the exponents. All right, so I'm just going to write 0.009 here, but I'm going to keep all those other decimals in my calculator. All right, so now if I want to calculate m, I've got to, little m, sorry, I've got to calculate or manipulate this formula. So I'm going to multiply both sides by big M. All right, so we're looking at that. That's going to be 184.71 grams per mole multiplied by 0.009 moles. The moles will cancel, and I'll be left with grams. I think it comes out to 1.64. Is that right?
Yes, but it's 182 grams.
Oh, sorry, 182. Yeah, 182. Okay, so it's going to come out to 1.64 grams. Okay, that's a small amount, and it kind of fits. I mean, if 1 mole is 182.7 grams, that kind of makes sense for like 9 1/1000ths of a mole. Okay, everyone okay with that? All right, how are we feeling about these? A little better? I mean, it's practice, right? We just have to practice them. Emily, question?
I just have a question about the last one.
Okay.
So, when I did the math circle a while back, I got 9 but I still have that.
Oh, yeah, that's the same number, they just put it in scientific notation.
Okay.
That's because that means 10 to the minus 3.
Okay, going to talk quickly here about your exam coming up next week before we get into any more mole equation problems. I'm going to post probably later today or early tomorrow a review package for you to use to study for your exam. That way you have it for the weekend. Okay, and that's not me trying to ruin your weekend, that's me trying to let you study longer. In this package, there will be a few things. There'll be kind of a review outline that tells you here's some things that you should probably do to study and prepare. There'll be some practice questions, and there will be a practice exam. Okay? The practice exam contains questions I no longer use, but used to be on the unit exam. It is basically a mirror image of the one that you will write next week. Okay? So the same kind of bones, right, for that exam as the exam that you will write. Don't do that first. Okay? There's a real tendency for people, I'm just going to do the practice test and see where I'm at. if you do the practice test first, what you'll find out is you need to study more, and then you'll have wasted the resource of the practice unit exam. So do the other stuff first, okay? And then maybe on like Tuesday, do the practice exam, okay? After you've studied and prepared, all right? Then the practice exam will tell you, okay, I'm not as good at predicting reactions as I thought I was, so I better go over that a little bit more. Now, you might be thinking, how will I know? Well, I'm going to include a key, okay? The practice exam will also have a key, right? So you can check it and mark it yourself and see how you do.
So the quiz or the test on Thursday,
I believe so. Isn't that the 10th?
Yeah.
Yeah.
Are we still having a quiz?
No, on Friday we'll go over the test. There'll be no quiz next Friday because I'll have nothing to quiz you on it. I might have taught you 2 lessons in biology by then, so. All right, so I'm looking at kind of doing mole equation today, quiz obviously on mole equation tomorrow. Okay, Monday I'll do a formal unit exam review in class where I'll talk about the test and all of that. Okay, go over a few key things, and then you'll have some time in class on Monday to study. Okay, and then probably Tuesday and Wednesday we'll be into biology. Okay, we'll kind of see how the quiz on mole equation goes. If we need to spend another day on it, we will. If not, we'll start biology then. Alex?
How long is the test gonna be?
Oh, you'll need the whole period.
Okay.
Yeah. Most people take, an hour to an hour and, 15 minutes. You have 90 minutes to write it, so okay. You got lots of time to write it. Okay? You shouldn't have any trouble getting it done.
How many questions is it?
Off the top of my head, I don't remember because I kind of just finished it, so I would have to look. I'll tell you on Monday when we do the whole unit exam review, I'll have it finished and ready then. Okay, any other questions there? So I will post that probably today so you can start having a look at it. Right? It's a pretty thorough package. Right? If you do that whole package and the practice test, I would say you would be well prepared. Okay. Is that the only thing you should do though? No, I'd still, look over my notes, do some practice on the worksheets, because you got keys for those as well. Okay, those would all be good ideas. All right, I would like you guys, right now, we did some of these ones yesterday. Okay. Actually, let's talk about number 7 right now. Okay? Which contains more atoms? A mole of iron or a mole of oxygen gas? How many of you are thinking, Coder, isn't it the same as asking me which is heavier, a ton of feathers or a ton of bricks? Is it though?
Well, maybe, but it might be different because of the O2.
It would be different.
I don't know.
Okay, remember that this is saying, do you know the difference between an atom and a molecule? Remember that if I have iron, I just have single iron atoms. If I have 1 mole of iron, I have 6.02 times 10 to the 23 atoms of iron. If I have 1 mole of oxygen gas, I have 6.02 times 10 to the 23 molecules of oxygen gas, each molecule containing 2 atoms. Okay, everyone following the difference there? Okay, 1 mole of oxygen is still 6.02 times 10 to the 23. But remember, oxygen comes as a molecule. Okay, iron comes as single atoms. Okay, so yes, the mole thing that we talked about the other day, yeah, 1 mole of anything is 6.02 times 10 to the 23 of that. But remember, that number is particles. If I'm dealing with a compound, I would have 6.02 times 10 to the 23 molecules of that stuff. If I'm dealing with a single element that's not a special element, I would have 6.02 times 10 to the 23 atoms of that stuff. 1 mole is always that number. But what are you dealing with? Are you dealing with atoms or molecules? That's basically what that question is trying to outline. Oxygen's a special element, so if I have 1 mole of it, I have 1 mole of O2. Everyone follow? Okay. Okay, I would like you guys to roll over. There we go. Okay, just have to wake up the hamster. You may. All right, I would like you guys to try these mole equation questions. They're not, the math of them is no different than what you've been doing. But I word them so that they're like a story and you have to figure out what's important in my story. They're crappy stories, they're not exciting at all, okay? But you still have to read the whole question and get what you need from them, okay? This is kind of preparing you for how things go. Okay, by the time you get to your diploma exam in chemistry or biology or physics, they've got some questions where you like read a page and a half of text and then they're like, use the page and a half of text to answer the next 16 questions. And you're like, okay, so this story I read, now I have to answer this question. Then I have to go back and read the story again to answer this question. We just want you to get in the habit of being able to read something and get stuff out of it so you don't have to read it a bunch of times. These are very short stories.
The answers are already on the screen.
I am aware. They're there so that you can check and see if you did it right. Yeah. Okay? All right. Give those ones, give 1 through 4 a try there. Okay, so we've got 77.5 grams of phosphorus. Now here's the thing we need to know, okay? Molar mass says phosphorus looks like this, P4. Okay? So I need to get its actual molar mass, which is 30.97 times 4. Okay, so 30.97 times 4, okay, 123.88 grams per mole. Okay, now that's the molar mass of a phosphorus molecule. Okay, so now I've got the mass as well, okay, 77.5 grams, so I can calculate the number of moles, okay, and will be 77.5 divided by 123.88. Okay, so the number of moles of phosphorus is 0.63. I'm going to keep all the decimals, I'm just going to write 0.63 moles. Okay, now if I take that to calculate the number of molecules, I would multiply by Avogadro's number, 6.02 times 10 to the 23. Okay, so I get that number. Okay, that is the number of phosphorus molecules. The question wants the number of phosphorus atoms. So if that's the number of molecules, what do I need to multiply that number by to get the number of atoms? 4. Now I have the number of phosphorus atoms. Okay, so it's the same as the oxygen question we just talked about. Which has more atoms? Okay, 1 mole of oxygen or 1 mole of phosphorus?
Can you explain that though?
Can I explain it?
Yeah.
When I have 1 mole of oxygen, or sorry, when I have 1 mole of phosphorus, I have 6.02 times 10 to the 23 of these. That's a molecule. It's 4 phosphorus atoms joined together. Right? So when I calculated this number right here, okay, and I got it to be 3.76 or 3.77 times 10 to the, what was it, 23? Okay, that is the number of these molecules of phosphorus because I used the molar mass of phosphorus molecules, right? So when I calculated this number, that's the number of molecules. Each one of those molecules contains 4 phosphorus atoms. That's why I multiplied that number by 4 and got the answer on the key. That's the number of atoms of phosphorus, not the number of molecules of phosphorus. Does you follow the difference there? So if I asked you which has more atoms, a mole of oxygen or a mole of phosphorus, the answer is a mole of phosphorus has more atoms. Because a mole of phosphorus is a bunch of P4s, right? Whereas a mole of oxygen is a bunch of O2s.
But how is there more atoms than molecules?
Because each molecule has 4 atoms.
I keep flipping back and forth in my head. So
Do you follow them?
there's 4 atoms in every molecule.
In every molecule,
Okay,
yeah.
But didn't you already times P by like the 30.797 by 4?
I did.
To get your molar mass?
Yeah.
There?
That's the molar mass of 1 molecule of phosphorus. Okay?
Wait, why did you times it by 4, just to divide it by 4?
We didn't divide it by 4. We multiplied it by 4 again.
How did we get the final part? We got the 3 point, I think,
3.77 times 10 to the 23?
was that the final answer?
No, that's not the final answer. That's the number of molecules of phosphorus. Okay? Then I multiplied that number by 4 again in my calculator to get the number of atoms in there. Okay? I'm not going to ask you one like that on a test. This is like, it's just, I want you to understand that some things, some of our special elements are molecules, not single atoms. Okay?
Does that mean like if it was like oxygen in the place, you would times it by 2?
Yep, exactly.
And sulfur you times it
By 8. Yeah,
And then 8 again to find.
right. Exactly. Okay, how many people have done number 4?
No.
No, not there yet? Okay, I'm just gonna move number 4 up there because we talked about number 3 already. Okay. Just so you know, I did just post the review package because I didn't want to forget and it was in my head, so I did it because I'm old and that's what you do when you're old. Okay. And I emailed your parents just to let them know that your exam is coming up next week. I hope that doesn't, spoil any of your exciting plans. Okay, but I let them know that that's coming up. And I also told them that I put the review package in Google Classroom, so they may ask you about it, just so you know, I went behind your back. That there's an exam coming and that I gave you a bunch of things to help you study. Okay, now, if you're starting to panic about this question, don't. Okay, it's not gonna be anything like that on your quiz or your test. Just the standard mole equation questions. Okay, 4 types. That one's just there to remind us some elements are special.
Can't you just solve the same by not multiplying it in the molecules? Like,
If I go 77.5 over 30.97?
That's what
Yeah.
I did.
Yeah, oh, okay, and then, okay. Hadn't thought to do it that way. By Avogadro's number?
Yeah.
Avocado? Yeah. I had, what did I have yesterday in period 2? Alessandro? I think. There's always good ones, I love it, it's fun. Okay. Yeah, you totally could do it that way. I hadn't even thought to do it that way.
Not that much easier.
It's much easier, yes. It's gonna get you the right answer. It may not be technically correct, but it works, right? The purpose of that question was to illustrate, hey, you got 4 atoms in a phosphorus molecule, right? Yeah. Yeah, it'll work. It would work if you did it that way. If you did this. If you just did it as a single phosphorus molecule, or sorry, a single phosphorus atom, it would work good enough for that.
so would that work just for this specific question, or would it work for?
Just because of the way I worded it, yes.
Okay.
because I went back to atoms. Had I asked molecules, you couldn't do it that way, right? So yeah, because I asked about atoms, you could just treat it like it's a single atom and go from there and it would work. Right? But if I asked you how many molecules of phosphorus are there and you did it that way, you would get an answer 4 times too big. Yeah? Okay, all right, let's see if you guys can finish up number 4 here. Hey, if you're done number 4, you can maybe try number 5 there. Okay. But yeah, definitely have a look at the review package tonight. Don't try to sit down and do the whole thing. It's way more than you can do. Okay, take away at it. Okay, kind of plan. You've got a week. Okay, kind of plan. All right, I'm going to do a little bit on Saturday. I'm going to do a little bit on Monday. Okay, but plan it out. Set some time aside. Okay, to work on it. And like I said, we'll do a formal review on Monday in class after we go over the quiz.